In this video, I will be talking about implicit differentiation and how to use this to solve for derivatives. So first off, we're going to use this when we want to find y prime, or in other words, dy over dx. And we're also going to use this for any equation where the y term is not on its own. And what I mean by this is we would have within our equation a y squared, y cubed, cosine of y, etc. And using implicit differentiation will make it easier for us to solve for the derivative. Right, for my first example, I have x squared plus y squared equals 25. And I want to find dy over dx, which is going to be our y prime. So this states dy over dx is the derivative of y with respect to x. So first off, I'm going to take the derivative of this entire equation with respect to x. So I will put d over dx in front. And as we know, as a rule for derivatives, the derivative of a sum is the same as the derivative of each term and then adding them. So I'm writing this over here. D over dx of f plus g is the same as d over dx of f plus d over dx of g. And because of this, I can apply the derivative to each term. So I have d over dx of x squared plus d over dx y squared equals d over dx of 25. So we know that the derivative of a constant is going to be 0, and the derivative with respect to x of x squared will be 2x. But now here we have the derivative with respect to x, but we have a y term. So we can't do anything here yet, so instead we'll multiply by dy over dy. And we can cross multiply the dy and dx here. And then we will have d over dy of y squared times dy over dx. And we were able to do this because since all of these terms are being multiplied, it doesn't matter what order we switch around the terms, it'll still have the same meaning. And now we have the derivative with respect to y of y squared, so that will be 2y. And then we have dy over dx, which is just our y prime, equals 0. And now we're going to want to subtract 2x from each side, and we'll get 2y times y prime equals negative 2x. Then we'll divide 2y from each side to get y prime on its own. The 2y's will cancel, and the 2's will cancel on the right, and we're left with y prime equals negative x over y. So this is our derivative, and then if they were to give you an x or y term, you could plug those in. So pretty much we're just going to apply the chain rule to the y term. In each y term, we're going to take the derivative with respect to y, and then multiply by y prime. For my first example, I have 2x cubed plus x squared times y minus x times y cubed equals 2. and we want to find dy over dx. So once again, I'm going to take the derivative with respect to x of the entire equation. And I'm just showing this step just to make it a little more clear, but you don't have to write it out this way when you're solving. You can just go right ahead and take the derivative of each term. You don't have to necessarily write it in this notation here. I'm just doing this to make it a little more clear. So we have the derivative of 2x cubed plus the derivative of x squared times y minus the derivative of x times y cubed equals the derivative of 2. So for our first term, we have in terms of x, so we get, using the power rule, 6x squared. And then for our next term, we have two functions being multiplied, so we can use the product rule. So the derivative of the first term will be 2x, and then times y, leaving that one the same. Then we'll do plus x squared times the derivative of the second term, which will be 1, and then we'll do times y prime because we're applying the chain rule to the y term for implicit differentiation. Now we do minus, once again we have the product rule for this one. So we'll get 1 times y cubed, and then plus x times the derivative of y cubed, which is 3y squared, and then we have to multiply by y prime. Since every time we see a y term, we're going to have to multiply it by y prime, even after we take the derivative of that term. And then this will all equal 0. So now I'm going to do some simplifying here, so I get 6x squared plus 2xy plus x squared times y prime minus y cubed plus 3x y squared times y prime. Once again, I'm going to do a little more simplifying and distribute the negative through. And now at this point, I'm going to want to subtract over to the other side all the terms that do not have a y prime attached. So on the left-hand side, I'm left with x squared times y prime minus 3xy squared times y prime equals negative 6x squared minus 2xy plus y cubed. And now I'm going to factor out our y prime, so I get y prime times x squared minus 3xy squared. And finally, I'm going to divide x squared minus 3xy squared from each side. And then all I'm left with is negative 6x squared minus 2xy plus y cubed divided by x squared minus 3x y squared. And this will be your equation for the derivative of y.